The next question is on volume. This is a question, I would say, very unique question. The volume is there's a container inside. Then this container is being like turned around from horizontal become vertical in part B. Okay, the way of doing is still the same. Do remember very clearly what you know about volume. Understand that uh when you are tested in prelim, when you tested in PSLE, it will not be always the standard question that you usually see, okay? But it's definitely based on the information you know regarding the topic. So at one glance, and we know it's talking about water, we have the water level, the measurement and all this. We know that we are dealing with this topic called volume. And it's always good to tell yourself that, hey, this is the formula I want to use. I write it down first. So it actually set the stage for you. The question that, hey, I need when I wrote this question, right? I need to look at the volume. I need to know what's the length, the breadth, and the height. Okay. When we are talking about measurement, always remember measurements must always be in the same units. If you happen to see that any of the units are not the same, please change them first before you start your calculation. Okay. Okay. First thing, a cubic container. So the big container that you are seeing right now is a 30 by 30 by 30 container with 9,000 cm cube of water. This 9,000 cm cube of water very important. You must know that water will not be more or less unless you add or you pour it away. Okay, or you remove or you really pour it away. Okay, if not, the 9,000 cm cube of water will always be 9,000 cm cube of water there. Okay, then next, a metal block. Then this one is talking about the darker color that they draw inside. The smaller one is 18 by 10 by 10. Do you realize that the figure A that you see is a 2D diagram? It's not a 3D diagram. You must understand that this is 2D, is what you see in front. What exactly the tank is a 3D diagram, okay? It's a tank like this. Bear with me, I'm also not very good in my drawing, so roughly lah, huh? Okay, so this is a tank that you have, and you have water. Let me draw the dotted. So you have some water inside. Let me try to make it as good. I try lah, huh? I'm also not good in drawing. Okay, so this is the water that you have over here. Okay, this coloring is okay. So I don't. Okay, so this is the water. In this water, I still have a container inside. So, yeah. Where is the container? I don't know. From the front view, it looks like right in front. But you remember it is this, wait, let me put in this one. This is 30 by 30, and this whole thing is 30. Okay. So, maybe I can shift the water level a little higher. Ooh, okay. Not so high. Okay, to give you the little, okay, something like that, huh? Then you have a cubic inside. This one will be smaller. You can see that this 18 is smaller. The side is also smaller. So bear with me. I'm not very good in my drawing. Okay, so something like this. Oh no, the lights cannot see. Wait, let me draw already. Let me put back the lines. Use this. Uh, maybe the short a little shorter. Okay, so roughly lah. Okay, trying to make it as a 3D diagram so you'll be able to see it slightly clearer. Okay, I push it all the way to the front. It may be in the center, I don't know, but definitely there are some space behind. You can see that there are some space on the side, some space down there, like how you show it over here. So that's the 3D diagram. So do remember behind still got space because it's only 10. This part here is only 10. It's 10. Yeah, 18 by 10. So this part here is only 10. So behind still got space. In front still got space. Not this one. See the in front, the left and the right side still got space. And the height here is 10. Okay? So it's a block like that. In a 3D diagram, it looks like this. So what do we know is that we know that of the volume is fixed, that's for sure because it's solid. So we know that there's a solid inside. We want to find the height of water level in figure A. So the height of the water level, will depend on the volume of water plus the volume of the metal block. Then we'll give you the height. Okay, so if you want to find the volume of water is given. We don't need to find. They tell is 9,000 cm cube. We need to find the volume of the metal block. So the volume of the metal block, the length times the breadth times the height. So total volume will give you 1,800 plus your 9,000, 9,800. So this 9,800, I want to know where is the height. So we need your length times your breadth times your height to give you 9,800. The container is 10, 30, 30, and I don't know the height. So I leave the height as height. And I find my height. So I get, yeah, I count wrongly. Yeah, I count wrongly. I forgot to add one more thousand here. Hi, calculation error. 1080. So this is 12 cm. So part A, 12 cm. Okay, this is part A. So I'm done with part A. Okay, so part A means the volume of your water plus the volume of your tank. And then from there, you put it back to the volume of the container to find the height. So that's part A. So I'm going to make this a little smaller, put on top. So I'm done with part A. Now I do part B. So what happened? The block, instead of put like that, right? They turn it, shift it up. So the block now is standing and push it all the way to the left-hand side. So we can see that this portion here is exposed. We have, not exposed, this portion here is filled with water. So this portion here is, the total here is 30. So this portion here is like another 20 cm that is filled with water. Okay? But if you look top down, you must remember that volume is equal to length times breadth times height, right? So you must also see not just the front view, which we are seeing right now. We need to know what is happening. Okay, so we know that water, when you fill the water, it has to flow around the container. So it's always good to look from the top view. Okay, from the top view, this is where the block is. And this block, they say that here is 10. And we know the block now is the height is 18. The height we cannot see. From the top, we know that it's 10 by 10 because it's a square, right? So, sorry, I need to draw a square. So it looks like this, okay? Then it looks more like it. This is 10 by 10. This cube here is 30, here is 30. So everything is 30. So we can see that the water will be filling up this area. And here is all 30 and 30. So the water is going to fill up this portion. All the water will flow in this corner and then form the height in this corner. So this is where the water will be, and this is where the water level will be. Because the water will not cover this thing, can you see? Will not cover all the way upwards. That means the volume of water is lesser. The volume of water is lesser, it's only covering this blue color portion. So we only need to find the length times breadth, which is the area of this blue color portion, and then from there find the height. Because we do know the volume of water is 9,000. So what we don't know is this blue color area. So how to find this blue color area? We can cut the diagram up. You have a 20 by 10. This portion is 20 times 10 to give you 200. This bigger one is 20 times 30. So the area of this is 200 plus 600 to give you 800. So the length, not the length times the breadth lah, huh? I will call it the area of the blue color is 200 plus 600 to give you 800. Okay? I want to find the height of the water, so I need length times breadth times height again. The length times breadth, this one gives you the area. So the 800 height equals to the volume of the water, and I divide. And that's my answer. 11.25. Yeah. So both way of doing a little different, okay? The first one is because the whole block is submerged inside the water. So when it's submerged inside the water, you add the volume of the block plus the water. So then you find the height, because the height will be 30 by 30 lah, huh? But for the second one, the block didn't submerge inside the water. So the block is like pushing all the water away. Hey, you all go outside, you only can feel the area outside. Okay? So only the area outside. So the length times breadth is the area outside. The area is no longer a rectangle anymore. It's like a rectangle, a big rectangle and a small rectangle. Okay? So if I have the area, I will be able to find the height. So do remember, when I teach during a lesson, I said before, length times breadth times height is the general formula. Length times breadth, you know, is an area. So actually volume is what we call the base area times the height. So if you're talking about a circle, right? You want to find the volume of this this cylindrical container, right? It's the base area of the circle times the height. Why? Because you can see that if I go and cut, right? Everyone see I cut, right? It's a circle. It's all a circle. So I multiply that circle based on the height, right? That will give me the volume. So same thing for this. I need to find the area of that outside that the block the water cannot flow on, right? That portion, the block actually block the water from going to the block area, right? So the remaining is all the area for the water. So from there, I can find the height. Okay? Can?